Identification papers ready. Keep the line moving efficiently now.
Manifest says 50 units of bakelite. Did they check out?
Yes, sir. All accounted for and up to spec. Stamping now.
Check the gain stability on rack 12.
It's drifting out of spec. Pulling this one now.
Power output is stable. Looks like a pass.
Confirmed. Documenting the results now.
As the glass rotates, technicians apply the precise phosphor suspension. Once dried,
The assembly line mates the faceplates and neck sections, applying the glass frit paste before they enter the infrared furnaces for sealing.
Brightness uniformity looks good across the grid.
Agreed. Ensure the high voltage reading is logged before burn-in.
Essential for every radar circuit, the carbon mixture is extruded and fitted with lead wires. After firing, the components receive
Power levels look good. Go ahead and stamp it.
Wait, this one failed the frequency sweep. It needs troubleshooting.
This is the heart of the radar system, the receiver assembly line. Technicians install sensitive RF
Precise torque is critical for the waveguide assemblies. After the initial build, compressed air verifies.
Keep a close eye on that count. We need exactly 200 turns for the high voltage.
Got it. Stacking the insulation now.
Double-check the insulation on those cables. We cannot afford any errors at this voltage.
Ramping up to full load now.
Voltage at 5,000. Corona is stable.
The waveform is drifting slightly. Adjust the timing capacitor.
Okay, it's stabilized now. The synchronization is accurate.
Sir, the waveguide connection to the antenna is secured.
Verified. Cross-reference with drawing 4B.
Power levels look good. Bring up the receiver.
Copy that, Supervisor. Receiver online. We have a sweep.
Bearing check at 350. Solid match on the timing marks.
Calibration successful. Green across the board.
Rotation is smooth. System approved.
The output is stable at 40 kilowatts.
Noted. Frequency confirmed. Reducing the input power now, we're at negative 110 dBm.
Okay, we're holding detection at 112.
Record that as the threshold. The noise figure is optimized.
Check the 5 microsecond mark. It aligns.
Confirmed. Recording the settings now.
Target return confirmed at specified bearing.
Check. Power levels stable across the band.
The azimuth resolution is well within the specified parameters, sir.
Sure. Let's verify the output stability under load.
The radar systems are carefully packaged in custom crates with internal shock mounting and moisture barriers before being stenciled for their combat zone destination.
Verify seal on crate 3. Sign here for the radar unit.
Confirmed. Signing now.
Easy on that starboard side. Watch the cabling. Copy. Lifting now. All right, team. Let's move this equipment efficiently. Forklift, you're clear on the left.
As we remove the casing, note the connection points for the main antenna awry. Handle these with extreme care during assembly.
So the propagation of these waves is crucial for accurate target detection, as you can see in the diagram.
Sir, how does this apply to the magnetron we examined earlier?
Identify the target separation.
Sierra 5, bearing 290.
Good, now track the velocity on that return.
What's your reading on the scope, Specialist?
The waveform is stable now, Master Sergeant.
Good. Now reinstall the chassis.
Lift, lift. Clear the mount. Secure the waveguide. All right, time 15 minutes, 22 seconds. Good hustle, but review the cable routing procedure.
Attention all graduates. By the authority vested me, you are hereby deployed to active combat theaters. Private Smith, Naval Codico.
This strategic coastal position offers long-range surveillance, crucial for detecting enemy threats before they reach our shores.
Aligning mount point 3, confirm stability.
Stable. Engaging impact wrenches.
Power connection successful, ready for system activation.
Hold steady on the crane. We're almost aligned. Confirmed alignment. Power levels stabilizing in the CIC.
The integration of this airborne radar gives the crew the capability to detect targets in darkness and through clouds, where vision...
Sierra onto site 63 is operational. Radar sweep initiated. Copy that. Maintain surveillance.
Sector, this is Coastal 1. Contact bearing 050, range 20 miles, speed high, inbound.
Scramble Alert 5. Verify identification immediately.
Phoenix 654, multiple bogies bearing 290, Angels 12. Requesting immediate scramble and intercept.
Contact bearing 090, range 100.
Confirmed. Large formation incoming.
Vector able squadron to intercept. Scramble immediately.
Intercept complete. Multiple splashes confirmed.
Roger that. All remaining bogies are aggressing, heading 290. Contact bearing 09ers, sir. Possible sub.
Acknowledged. Helm, right full rudder, new course 320. Alert the air patrol. Contact bearing 040, range 15.
Roger that. Turning to intercept.
Steady, steady, closing to 5 miles.
Target approaching from the northwest, bearing 320. Fire control, engage at will. The barrage is effective.
As you can see on the main display, the increased jamming attempts correlate directly with the movement through the northern corridor.
By adjusting the pulse repetition frequency here, we significantly improve the detection range.
The resolution on the new display is far superior.
And the receiver circuits are much more compact now.
By systematically upgrading the deployed systems, we ensure combat capability is maintained without lengthy factory returns.
Look at the scope now. The frequency hopping is working. The return signal is clean.
We have successfully rejected the interference. The countermeasure is stable.
Thermal characteristics are stable even at high altitude simulation.
Excellent. This confirms the miniaturized design meets all specifications.
The target return on Sector 3 is still showing latency.
Let me adjust the pulse repetition frequency, and we'll compare it to the recorded signature.
The core innovation here was the cavity magnetron. It allowed for the higher power output we needed.
Right, and understanding its failure mode. By simplifying the interface, we've made it suitable for commercial vessels and far cheaper to produce.
Excellent work, the integration is seamless.
It's incredible how quickly they developed this.
Yes, truly the decisive advantage in the Battle of Britain.
Apply the heat evenly to the joint, Miss Johnson. Remember, a cold solder compromises the circuit.
We need those radar components moved to the priority staging area now.
Copy that.
Moving the scarce materials pallet.
The thermal imaging shows a clear hotspot here. And the power signature confirms the instability at high frequency.
The vibration analysis confirms the bracket failure in the field reports. This revised design resolves the issue. Supplier sees delay on the transceiver modules is impacting the timeline.
We can shift internal resources to compensate.
We need 3 more men on the wiring harness immediately. Keep that line moving.
The magnetron's efficiency is unmatched. If we coordinate production, utilizing your facilities in the States, we can equip the fleet within the year.
Make sure that latch is secure. We can't afford any losses on this run.
The Soviets are waiting on this radar shipment, Captain.
Confirmed hostile track, bearing 270.
Scramble all available squadrons. Vector immediately for interception over the channel.
Contact bearing 045, range 2,000 yards. Surface runner.
Hard starboard, prepare the K-guns. Fire when ready.
Stand clear, fire 1.
Data confirms position over coastline.
Roger that. Target acquired. Dropping ordnance now.
This next-generation system processes radar data, calculating the precise intercept solution for the guided missiles.
The civilian models require a much finer calibration than the military units. Pay close attention to the wiring harness.
The Hurricane is maintaining course. Advise immediate evacuation for Sector 4.
Yes, sir. Sending the warning now.
Delta 49er Heavy, runway 27 right, cleared for takeoff. United 105, descend and maintain flight level 200.
Steady as she goes, officer. That contact is passing astern. Roger that, Captain. Confirming new course 290. We have a clear return on the meteor shower. The radar is tracking the decay perfectly.
Noted. The data confirms the atmospheric density models. This cavity magnetron was the key to centimeter radar. Notice the interaction between the magnetic field and the electron stream.
How does the output couple to the waveguide?
From its origins as a wartime secret.
Attention all personnel. The security of this facility and the success of this project are paramount. Any breach threatens the lives of our soldiers.
When is ready to say so? We must prioritize interchangeability for field maintenance.
This 6L6 specification achieves that balance.
This sequence here is critical for the phase array alignment.
And these procedures ensure consistent quality across all new facilities.
Your eyes are clear, but remember, the goggles must stay on near the flux.
Ensure the soldering is clean on that connection, Margaret. We can't afford any failures in the field.
Yes, ma'am. Right away.
Sustained production is key. The radar output is critical for the war effort. Let's maximize every hour.
The vacuum tube shortage is crippling radar output.
We need to fast-track the new supplier in Phoenix.
And authorize the CapEx for the expansion immediately.
The thermal cycling confirms the oscillation near the cathode limit. This explains the intermittent drops in power output.
We need...
Falcon 3-0, Vector 290, bogey at Angels 25. Intercept authorization granted.
Target at 20,000. Elevation 40. Fire! Fire!
The systematic analysis confirms the enemy is utilizing these 4 primary routes.
And the timing suggests a coordinated strike capability within the next window, sir.
Deploy the mast, check the power lines. Generators are a go. System operational, scanning.
Aegis 4, confirmed track 779 is correlated.
Affirmative. Sector 3 coverage overlap resolved. Data fusion is green.
Time for your rotation, Daniel. Get some rest.
Acknowledged, boss. Thanks.
Shore control, we have multiple inbound threats, bearing 270. All air assets, Vector 4 intercept. Weapons free on identified bogies.
Ensuring the safety clamps are secured.
That film sequence is perfect for the new technicians.
I will reference the exact timestamp in the digital manual.
The breach occurred on your watch. We know the enemy has this data now. What did you do?
I followed every procedure. I can't explain the discrepancy.
The fleet requires immediate allocation, Admiral King insists.
And the Air Force needs protection for the daylight raids.
The Pacific Theater needs these naval systems now.
We understand, but capacity is limited. Air defense must come first.
Agreed. We are prioritizing air defense for this quarter.
With the war concluded, the massive wartime workforce had to be demobilized. Peacetime conditions meant a dramatic reduction in military orders.
Clipper 714, cleared to the LaGuardia range station. Maintain 3,000 feet.
This award signifies your commitment to excellence, a commitment that directly supports our soldiers in combat.
These magnetron designs are critical for the cavity optimization.
Yes, securing the IP now will be vital for post-war applications. These systems must be operational across the Atlantic corridor by July.
We are prioritizing the French sector allocations now.
The analysis is complete. Interception probabilities rose sharply with radar direction, proving the massive return on investment in the program.
Vector 390, engage at will. Splash 1. I repeat, splash 1.
You're doing good work. Keep breathing. Next one up.
We need more coverage on the upper quadrant. The reflective signature is still too high.
We must emphasize that enemy acquisition of radar secrets is a constant threat. Security vigilance is everyone's.
See how the waveform is distorted here. That's not within tolerance. Now, isolate the input signal.
We have the replacement magnetron ready. Scan the manifest and seal the crate for priority delivery.
Roger that. Manifest scan.
Approaching the IP. Crosshairs aligned. Stand by for bomb release. Sector 4 is clear. Copy. Maintain vigilance on the eastern approach.
Over.
The core principle relies on the Doppler effect to measure velocity, as shown here.
The phase alignment seems slightly off.
The new tooling has significantly improved the cycle time.
Yes, the fatigue scores are down, and output is up by 20%.
By cycling the equipment through extreme temperature and humidity variations, we can accurately predict field reliability.
The secondary structure is gone. Impact coordinates confirmed.
Significant damage assessment confirmed. I'm updating the report now.
His spatial reasoning scores are high, but look at the error rate during the attention span phase.
He struggles under high load. We need consistent performance for radar duty.
Radar, the silent sentinel of the skies.
This location optimizes the radar coverage, minimizing terrain blockage.
Agreed. The logistical challenges are manageable, according to the survey team.
The rapid scaling of production required unprecedented coordination between the labs and the factories.
It was remarkable technology for the time. We tracked them right across the channel, clear as day. We knew we were making a difference.
The post-war electronics industry landscape, as companies founded by radar veterans commercialize military. From the bulky, rotating antennas of World War II to the sleek phased arrays today, the evolution of radar has been born.